I'll just run through the setup actor, which is just an actor blueprint. I tend to just keep it at the origin so I can find it very easily. And let's dive into the blueprint. So looking at the components, usual trick, I just have a post-process volume in there because I put them in my setup actor so that I can easily reference them rather than it just being a post-process volume in the world. Looking at our begin play, what have we got? We've got a get actor of class where we're looking for our first person character and then just saving that as a local variable, FPC. In the sequence, we are then looking at the helicopter body actor, which again, saving locally, accessing its static mesh. If you recall, the static mesh of the heli body has got two sockets. So here I'm getting all socket names, and then I'm just getting the first in the list and the second in the list. There's only two sockets, so this is hard-coded, it's not dynamic, purely because I know I'm dealing with that mesh. But what I am doing is that for the first one, which is the blade socket, I am spawning the actor heli blades actor, and I am then making that the target, which I am then attaching actor to component. The component being the socket name and the parent being the static mesh of the heli body. So that all goes into there, and just in terms of the rules, I've just put snap to target on each. So that happens for socket 0, which is blades. Socket ID 1 is for the tail, and exactly the same thing. I've got the socket name, which is tail. I'm spawning heli tail actor. I do have to split the transform, because if I don't, that will show an error. So just to get rid of that error, just split the transform and it gets rid of it. We don't enter any location information because we're snapping to the target, which is the socket name. Again, of parent, static mesh, which is part of the heli body actor. So that happens for those two sockets, and then I'm just getting that array, and then for each of those, we only have two, I'm running a for each loop, and I'm saying on each of those sockets, again using the attach actor to component, spawn a label marker, and our label marker is just our actor that we then reference in our HUD to project the world location to the screen position. And I'm doing that twice, and within my label marker blueprint, I've got a static mesh here, which is just this sphere, and I'm just setting the size of that to 1. The reason I'm doing that is because later on, as we're zooming in and changing the field of view of the first person character camera, I'm actually scaling that sphere as well. I do want it to be on screen, but I didn't want it to be massive on screen when I'm zooming right in, so we're kind of offsetting that. I'll show you that in a second. So labels hard. So obviously once we have got the helicopter spawned and more importantly the labels markers spawned into the world, we can then and only then spawn the label HUD, because the label HUD has got in its event construct, the first piece of code is saying look for how many of the label markers are in the world. So obviously we need to spawn them first before creating the UI Mat Labels canvas widget and adding it to the viewport. And I've just enabled some inputs in this blueprint locally so that I've got show mouse cursor, and then I'm enabling input because I'm using the scroll wheel for my changing the field of view, and then just setting the input mode to game and UI. So here, because we've now enabled that input, it means that we can add input nodes in this active blueprint. So just to reiterate what I said, we've got our first person character, we're accessing the camera, and then we are changing the field of view. So we're setting the field of view by taking our current field of view and adding or subtracting our incremented value. Let me just change that. Well, it's increment, decrement, because it's taking away here. Anyway, every time I'm moving the mouse wheel down a click, it is adding 5 to the field of view. And I'm clamping that to within a range of 10 to 90, so I can't go beyond those fields of views. And then I am also looking at the label markers. So again, here are our label markers. As mentioned, I'm accessing the static mesh. The return value, we know that we've set our clamp to 10 to 90, but I'm using a map range clamp node to take in that range of 10 to 90 and output a range of 0.3 to 1, which is then the value that this static mesh scales in the world. So there's no kind of tweening on that, it just happens on click. So it's not something you notice until you take it away, really. So almost the same thing for mouse wheel up, where we are subtracting 5. Increment value, decrement value is just being shared there, so it's consistent. So exactly the same thing there. And then I've then got, again, because we've enabled inputs, we can add keystrokes here. So I've got an event for when I press 1 on the keyboard. I have got a timeline which has just got an event track of very short, 0.3, with a keyframe by clicking shift and adding a keyframe just at the end there at 0.3. Value doesn't have any effect, so that can just be 0. But this is the only point at which it gets triggered. I have got loop on, so at every 0.3 of a second we are updating a couple of things. So we are getting the heli blades actor, and if you recall, we had a rotating movement component in there, and I am doing 2 things. I'm getting it, so this is getting it, and seeing what the rotation rate on the, in this case, the Z is, because the blades are running, rotating around the Z axis. Having right clicked and split the rotator pin to get these 3 floats. And I'm adding a rotation incrementer. So every 0.3 I'm adding 10. So 10, 20, 30, all the way up, but clamping it at 2000 degrees per second, I think. And then I'm setting that here. So we're getting the value, and because we're looping, it's just adding it. So when I press play and hit the keyboard, the blade starts quite slowly, and now it's probably 20, 30, 40, 50, 60, 70, 80, and on it goes, and you can see that the speed's increasing here because we've tied in that value to a material parameter collection. And when it gets all the way around, that will be at 2000. The rotation rate of 2000. So it's 2000 degrees. And there we are, that's the max speed, so it's not going to get any faster than that because we have clamped it. So because the blade and the tail, so here we have the tail, we're doing exactly the same thing. The only difference is that we're rotating around the x-axis because the tail is a different orientation. But we're only updating the material parameter collection for the parameter name pi_l, which is a scalar value in the material parameter collection. So we are taking that value, and because we've clamped it there actually, between 0 and 2000, so we know that that adding 10 will stop at 2000. But again, I'm using the map range clamped, that's unclamped. I never really know the difference between those two. I don't know what the difference, because there's 2. There's map ranged, I normally use map range clamped. I don't know what the difference is. If you do, please, please, please let me know and what the sort of scenario is. It worked, but I do normally use the clamped because that's in effect what I'm doing. Taking that 0 to 2000 as an input range and then outputting it to 0 to 1, because our material is drawing on an alpha range. A 0 to 1 range and is an alpha range. So at 0 nothing's drawn in our pie chart, and at 1 it's fully rendered as a circle. So that's being updated, converted to between the alpha range, which is then setting the scalar parameter in our material parameter collection, which is driving the large pie chart visual and how much of that segment is rendered. So I hope that video is of use. If so, please do like and subscribe and hit the notification bell to receive any updates. And thank you for your support.
Live long and prosper.